Good news, in this video we're going to be going back to quadratic equations, but with a twist this time. They're going to be involving complex numbers. Complex numbers in the roots, so basically the answer to the equation will be complex. Or even we can have complex numbers in the quadratic ourselves, as we'll see in part 2. We'll learn how to solve both of these types. And to help us though, we can still go ahead and use the quadratic formula. I've just changed the x to a z. Don't get too afraid by that. We just use z instead of x's for complex numbers. But really, you could go ahead and use any letter you want for these. That shouldn't trip you up. We could use the a's before. We've used all kinds of different letters, and we will continue to use all kinds of different letters. Going forward, you even use weird things like e to the x as your x. So that's squared plus 2 e to the x plus 3 or something equals 0. You could solve that quadratic equation because it's something squared times something. In this case, that something is just a complex number. And we tend to just use z, so don't worry too much about that. But really, I'd be happy to stay using x, really. I guess I've got into the habit. Okay, so we still have our old favourite, so let's jump right in and try and solve these. Because they're going to work very similarly. Let me rewrite this out. It's 2z squared. I'm missing a square up there, my bad. 2z squared plus 2z plus 1 is equal 0. As always, let's write out what a is equal. A is equal to 2. B is equal to 2, the coefficient of the x squared part. The number basically in front of the x squared. The coefficient of the x part is 2. And the coefficient of the no x part is c, which is equal to 1. Alright, this is just like we've done, so I'll go fast enough. It's z is equal minus b, which is minus 2, plus or minus b squared, which is 2 squared, minus 4a is 1, a is a 2, and c is 1. All of this is square root, and it's all divided by 2 times a, which is 2 times 2. Let's just fill everything in and try and clean it up. We'll get minus 2 plus or minus 4 minus 8, 4 times 2, square root of this over 4. Now previously we'd get to this point and realise, wait a minute, we have a minus number here. This is a problem. But it's not a problem anymore. The square root of minus 4, we can do that. Let's jump over here. We've minus 2 plus or minus. The square root of minus 4 is simply the square root of minus 1 multiplied by the square root of 4. We could have always done that. Let me put z in there. Z is equal to this divided by 4. We could have always done that. It's really the minus 1, square root of minus 1 to get us trouble. But no more, because we've defined that to equal minus 2 plus or minus square root of 4 is 2, and the square root of minus 1 is I. That's just what we call it. Whenever we get the square root of a minus, we'll call square root of minus 1 I. All of this is divided by 4, and therefore our answer is minus a half plus or minus a half I. So that, remember, is our two answers. Let's write out both of them separately just to be fairly clear about it. Is minus a half plus a half I, or our other answer is z is equal to minus a half minus a half I. So we get two answers. And one more interesting thing to note is these two answers here are the complex conjugate of each other. So remember what that is. It is when we change the sign of the value of I. So the coefficient in front of I was a half, and now it's minus a half. It was minus a half, it's now a half. They are the complex conjugate of each other. And that will always be the case. When you get one answer to be a complex number, the other will be the complex conjugate of that number. If all the coefficients of the quadratic are real. So in part 1 here we will get this case. We'll also get it in cubic equations, in polynomials of order 4, of order 5. This will always be true. If one is a root, its complex conjugate is also a root. But not true. It won't be true in part 2. We'll see that then, because its coefficients are not real, and we'll go ahead and see that. I guess one last thing, previously were drawing these, so this would look something like this. I'm not sure whereabouts. I guess it would hit at, I guess it would look more like this maybe. But the point is, it wouldn't hit the x-axis, and therefore it would have no real roots. Unfortunately though, I cannot draw 4 dimensions, so I can't show you where this does in fact hit the complex, the Argon diagram basically, of because I can't draw it. I can't draw an axis that is 2 dimensions. I can't draw one axis that's 2 dimensions. And this shape here would have to be in 4 dimensions for me to visualize that. But it does in fact hit somewhere. It does have roots. Those roots are just complex. I wouldn't worry too much about the picture. As you can tell from me stumbling, I haven't thought too much about it. I'm struggling because of that. Okay, let me go ahead and rub this out and we'll do part 2. Okay, part 2, as I already said, it has complex coefficients, and I'll spell that out a bit more by doing what I always do, by writing A equals, B equals, and C equals. So I'll ask myself, what is in front of the z squared? What's the coefficient of z squared? That one's normal enough, it's 1. But now we're getting a bit more difficult. I often say to students, what number is in front of the z? What number is in front of the z? What's the coefficient of z? And a lot of students say, not most, but a lot of students say 2. But no, 2 is a real number, but there's also an imaginary number. They're both together, they are a complex number. So what's really in front of it is the 2 minus I, but remember they're both even minus as well. Do not forget that minus. We often forget it in real or imaginary questions. So that's the coefficient of z. So if we multiplied all this out, they would all of these would be acting on the z. They'd all be multiplying on the z. The minus, the 2, the minus I, or I guess it's minus 2 and plus I is another way to write this. And then the coefficient that have no z's. The coefficient of z to the power 0, I like to think of it. But the coefficient that have no z, not 7, it is 7 minus I. But once we have that, it is now simple enough to just fill in. When I say simple enough, it's going to be a little harder than usual. But we still go ahead and use the same formula we've always used. Z is equal to minus B. That just becomes minus 2 minus I. So these 2 minuses out front will just cancel. We're left with 2 minus I. Plus or minus, I'll leave the square root to the end, but we get minus 2 minus I, all squared. Do not forget to square the minus. In fact, it's going to make it easier because it'll disappear. Minus 4, A is 1, and C is 7 minus I. So it's a bit of a mess, I'll admit. It is a bit more challenging. On the bottom row we get 2 times 1. It is a bit more challenging, all this, but really it is just the same as, it's just filling in an equation. So don't get too afraid by it. Okay, let's clean this up a bit. We get 2 minus I, plus or minus, and inside this square root we'll get, this minus by minus will be plus. 2 2's will be 4. Minus I by minus I will be plus I squared, which is minus 1. And then 2 by minus I is minus 2I. The same again is minus 4I. So that's all that multiply out. We don't need to worry about the minus because it became a plus. So I'm really just squaring this bracket here. Okay, this comes out as minus 28 is the real parts. And then minus, so plus 4I. Square root, all divided by 2. Now I'll point out that I was nice to you. Where I got this question was nice to us. It gave us an easy one because look what happens in this square root. Our i's cancel. But I will point out that we don't need that. In the next video, I think in the next video, I'll have to double check that. I will teach you how to get the square root of a complex number. It is doable. It's not actually that difficult. So we could go ahead and get the square root of a complex number. In this case though, they've saved us the trouble and these do cancel out. So let's clean this up even more. It's 2 minus I plus or minus. What have we got in here? 4 minus 1, 3. 3 minus 28 is minus 25. And that's it. Square root of minus 25 over 2. Let's continue up here. Z is equal. 2 minus I plus or minus. Let's get a little faster at doing these. Remember, we separate out into square root of 25. It's just 5. And the square root of minus 1 is just I. All divided by 2. So the answer is, two answers, remember, because it's not as easy to clean this one up. The two answers are Z is equal to 2 minus I plus 5 is plus 4I over 2, which is equal 1 plus 2I. That's one of our answers. The other answer, if this was a minus, is 2 minus I minus 5 is minus 6I over 2, which is equal to 1 minus 3I. These are not conjugates of each other. These are not complex conjugates. So that is a good bit different. So okay, that's how we get complex numbers. These questions are a good bit harder, I'll admit that. And in fact, they will get harder again if we were to have a complex number in this square root. But it is doable. Next video, I think I will. I'll probably change it now that I've said it so many times, to getting the square root of a complex number. So join me then, and goodbye.